Just forgot to unfreeze it. Okay, we've got quick review over finding the x-intercept, the y-intercept, and the slope, and graphing it. So I'm just zoom in so we can just see number one. Just to remind you that y equals 2/3 x minus 4, that is in slope intercept form. Y equals mx plus b. Our m is the slope. So what is our slope? 2/3. Okay. From there, our y-intercept is always, if it's in this form, our y-intercept is 0b. So in this case, it would be 0, -4. It has to be an ordered pair. If you just type in -4, it's getting counted wrong because it's not just -4. It's the ordered pair 0, -4. And then the x-intercept is the one that has a little bit more work. I need to change the thickness here. There we go. So I'm going to zoom in a little bit more. The x-intercept is plug in 0 for y so that we can solve for x. When we're done, the x-intercept is going to be something, comma, 0, because we're plugging in 0 for y. So in the equation, I'll have 0 equals 2/3 x minus 4. And I've been working with students, and some students are very weak in solving for x. So I'm talking to you. If you know how to solve for x, I'm very happy for you, but I'm just talking to you like you don't know what you're doing, okay? Even though you might. But there are some students that do not. So we have to get x by itself, and x is surrounded by stuff. Things are being done to that x, and we have to kind of like peel that stuff away. You can't do it all at the same time. We got to peel it by layers. So you want to take the outermost layer away first. So if you see 2/3 is next to x, and then there's a subtract 4. The subtract 4 is kind of the furthest thing away. We have to cancel that out. So you think about the inverse operation, the opposite operation of taking away 4, and you guys would tell me, well, that's addition, adding 4. That's how these go away and become 0, but you can't just do it to one side, you have to do it to the other. So now I have -4 equals 2/3 x.
You're adding.
Oh my gosh. I don't know why I did that. I did that to make sure you're paying attention. Good job. That was the only mistake I'm making the whole year. Okay. So now we need to cancel out the 2/3 and make it into 1x. So we need to undo multiplying by 2/3. So we're going to undo, let me say it again. We're going to undo multiplying by 2/3. You can do this in 2 separate steps. You can also do it in 1 step. So I know somebody out there said times by 3. You can do that. I'm going to do it in 1 step. You can do it in 2 separate steps. What is the inverse operation? What is the opposite operation of multiplication? So we're going to divide by 2/3. However, you can't divide by fractions. So instead of dividing by a fraction, you multiply by its reciprocal. And we do that to both sides. And then to multiply a fraction and a whole number, you got to put 4/1. And then you go straight across. I get 12/2, which is 6. Now, that is not the answer because it has to be an ordered pair. So my answer for x-intercept is 6, 0. That's my x-intercept. So we're going to graph our y-intercept, -4, our x-intercept at 6, and just use the slope to make sure everything worked out okay. So I could, from 6, go up 2/3, or from -4, I could go up 2/3. Or I could just use that pattern and go the other direction, which looks like it's down 2, left 3. everything fits on the same line, I'm good. Everything except for the line fit on the line. Okay, then we move over to the second example. Exact same stuff, different question, exact same stuff. So we're going to find the slope first, which is -3. Oh, actually, this is not almost, it's almost the exact same question. There's no y in this one. The f of x is the y. If we can write an equation in function notation, which we haven't talked a lot about yet. We write equations in function notation. That just replaces the y. It means the exact same thing as the y. It's just fancy looking. So that is the y. So our slope is -3. Our y-intercept is going to be at 0, 1. Our x-intercept, that didn't work. Sometimes my computer stops working for a half a second, but I'm writing, and it does that. X-intercept is going to be something, 0. Looking at this equation, I can't see it yet. We got to plug that 0 in for y, or f of x, and solve it. So I'm going to peel away the layers. The first thing I'm going to do is take away 1. I get -1 equals -3x. Divide by -3. That's not a fraction, so I can just divide it. And then I get +1/3 for my x value. So my x-intercept is at +1/3. My y-intercept is at 1. My x-intercept is hard to graph. So I'm definitely going to use my slope to kind of make sure I'm doing this right. I'm going to start at the y-intercept and go down 3 over 1, down 3 over 1, down 3 over 1. And as I'm doing that and following my pattern, it does look like the x-intercept will go through 1/3. So I feel pretty confident I have it right. But that's not a line. You guys have questions?
No.
I didn't know if Caleb had any questions. Huh? You got any questions?
No.
All right, now we're going to move on to some new vocabulary. We have not talked about this vocabulary yet. Okay? Functions that belong to the same family share key characteristics. So we're going to talk about what a parent function is. It's the most basic function in the family. It's like the mom function or the dad function. Okay? It's the parent function. The most basic. There are no transformations on this parent function. When we were on, that was yesterday for us, right? Yesterday? Okay. When we were on the TARP yesterday, we were doing absolute value of x a lot. And then we would transform it. But the absolute value of x by itself, you'll see right down here, is a parent function. So that basic function that has no transformations, there's only one in it, like multiply by 1. That is the parent function. The family, you can think about being like you belong to a family, and a lot of you might have the same last name as somebody in your family, and that might be like your family name. My family name, I'm married into my family name, so Criswell is my married family's name. My family name was that. Yeah, no. Nah. But I changed it when I got married because nobody could ever say it. And now, I will tell you, and now I regret it. Just saying, females who want to change their name someday, I regret that I changed it. No, I miss it. Because I spent 32 years as a Gianfagna. Rhymes with lasagna. Jen Fun, and I was Miss G at school. And now I'm just Mrs. Criswell, and it's not as exciting anymore. But anyway, I don't regret getting married. I just regret changing my name a little bit. Just a little bit. Okay. So the family name would be like your last name, perhaps, if you share a last name with family members. The family for this first graph is called a constant. These are the horizontal graphs, the horizontal. And we were graphing a horizontal right at the beginning of class yesterday. The diagonal lines, those belong to the linear function or the linear family. Mr. and Mrs. Linear had lots of linear babies, and they made a linear family. The absolute value family is what we were doing for the most part yesterday. And then this is called the quadratic family. And the quadratic family, we're going to spend 2 full chapters on. Chapter 2 and Chapter 3 are on the quadratic family. It's a pretty important family to spend a lot of time on. It's called quadratic formula because, how do you say this? X squared. And you get that by taking 2 sides of a square and multiplying it together for the area. You know, like centimeters squared or meters squared. So it's called a quadratic because this is a quadrilateral form. Domain and range, we started talking about when we were doing our name graph. That's where I first started talking about it. We're going to continue talking about it the rest of the year. The domain and range of each of these. So this is going to be the domain and range of each of these parent functions, but things change. They won't always be this when we start having transformations. So what I want you to do is remember with domain, those are all the x values. The range, that's all the y values. So for now, we're just going to look at this graph and say, x values go left to right. What do those arrows mean if it goes left to right? It goes on forever. There's no stopping it. So because it goes on forever to the left and to the right, the domain is called all real numbers. Because it's all of the numbers. All real numbers is a really long phrase to write. So mathematicians, we shortened it. We have a 1-letter abbreviation, so you don't have to write all those letters. It looks like this. Like an R, but it has 2 lines. So if you didn't want to write all real numbers, you can write the special R. That means all real numbers. For this one, we did talk about, when we did our horizontal lines with your name graph, we talked about the range for every single point up here. -3, 1, 0, 1, 2, 1. Like for every single point, the y values are all 1. So you just write y equals 1 if it doesn't change. For the line, we say how far to the left, how far to the right does this line go? Arrows mean forever. So all real numbers is our x values. Range is the y. So I'm going to highlight the same thing but say different words. How far down does it go? How far up does it go? Forever. So it's also all real numbers. Or if that's too long, you can go ahead and shorten it with the special all real numbers symbol. Absolute value that we've been working on. How far to the left, how far to the right does that go? All real numbers. Goes on forever. But it doesn't go down all the way. So those arrows only point up. So when we talk about the y's, we say, what is the lowest y? Thinking about the y value, what is the lowest y? 0, and then from there it goes up. So we have y is greater than or equal to 0. And then this last one, the quadratic, if you look at the shape of the V and the shape of the U, they're kind of almost the same when we talk about domain and range. They both go on forever, left or right, all real numbers. They both go down to 0 on the y and then go up from there. So they both have y is greater than or equal to 0. Again, we're not going to do a lot with quadratics yet. We save all that fun for chapter 2 and chapter 3. When we make tables of our parent functions, so these are the parent functions, we're going to specifically use points that make it very convenient for us to graph. I'm going to give you those points that we're going to use. On a quiz, if I said what points are the values that you're going to use for linear, you should be able to type in the right ones. So linear is f of x equals x, or you could say y equals x. The x's that we choose are a couple negatives, 0, and a couple positives. You should recognize these. They're the same ones we were doing when we did the TARP activity. Now, remember, with your x value, when you were standing out there, you had to put it into the absolute value, and then the output became the y value. This is the same way. I'm going to input -2 in for x. What do I get out for y? This is y equals x. I get out -2 because they just equal each other. I'm not doing absolute value yet. This is just a line. So if I input -2, I get out -2. If I input -1 for x, what do I get out? I get out -1. I get out 0. I get a 1 and 2. So that's the parent function points for linear. You need to know those. They're really easy to come up with. Absolute value. We were standing in those spots. -2, -1, 0, 1, 2. There might have been a group that had a 3 here or there, but and you can add on 3 if you want. But typically we take the ones that are just around 0. So these we should know because we were doing this. If we input -2 into the absolute value of x, if we input -2, what do we get out? 2. We get out only positives. And then we haven't done quadratic yet, but we can still make a table because quadratic is y or f of x equals x squared. And we should know those numbers. We should know what squared is. I do choose to add the 3's in for this one because quadratics are not straight lines. So we do need more points to make them look good. So I'm going to input -3 in for x. I'm going to input -3 right here. So we're going to do -3 squared. We're going to do -3 squared. -3 times -3. That's super mumbly, but I'm still afraid I hear somebody saying a negative number. If we do multiply 2 negatives, it should just be a positive. If I plug in just 3 times 3, that's also a positive. So kind of like absolute value, but not the same numbers. I'm getting out only positives. 1 times 1, 2 times 2, or -2 times -2 is positive 4. Just like absolute value, if you look at the like the numbers, they are symmetric, and then there's one very important one in the middle. Do you remember the very important one was called? Vertex. Very important vertex. Guess what? Same thing with quadratic. Very important vertex. And then we're symmetric from there. Quadratic also has a vertex. Again, that's for a different chapter. Here, complete the table by stating the family function, or function family, and then it says write the equation. I'm going to skip writing the equation for now. All right, so we're going to look at this, and it's a diagonal line. That is the linear family. Linear. This one is a straight horizontal line.
Constant.
That is the constant family. Then we've got this U shape. That is quadratic. The absolute value makes a V. Absolute value makes a V. So absolute value is this last one. Absolute value. There, I drew an absolute value V for my V. All right, let's move on. Let's move on. Identify the function family to what this graph belongs, and we're going to find the domain and range. Look at it. Looks like a V. Absolute value. Done. Not done, but like that part. Domain is the x's. Range is the y. So the first thing we're going to do when we find domain and range, we're going to look left to right. Look at the picture. Left, right. Does it ever stop? No. So what do I say? Okay, so I can write out all real, oh, my arm is hurting, numbers. Or I can put in the abbreviation for all real numbers. Range. How low does it go? And that is a y value because the range is the y. So it goes down to 1. It goes up from there. So we're going to say that y is everything that's greater than or equal to 1. And that is domain and range. We're skipping the next example. We're going to vocabulary word bank. We started talking about this stuff. I know I brought out every single vocab word that's in here, but we didn't actually get to do all of the transformations on the TARP yet. So we'll finish our transformations next block day, but we're going to start doing it on paper first. So translation is any time that the graph might slide left to right, up or down. We did a bunch of up and down translations. We didn't do any left or right. We will do a left or right today. Reflection, that would be where it like flips over. Reflection. We did this way. We haven't done the other way yet. Vertical stretch and shrink, we did a teeny bit of that. I still want to go over that more. And we're not going to get to it today. And then horizontal stretch or shrink, we haven't gotten to at all. We haven't gotten to any of the horizontals, but we will do one of those horizontal things today. Go to nope, not example 2. We're going to go to this example, the top example on the next page. We're going to go to example f of x equals absolute value of x plus 3. We're going to graph that. And we're going to graph its parent function. And we're going to describe the transformation. We're going to find the domain and range. We're going to do a lot. Do you remember where the parent function, just absolute value of x by itself is? Plot it. I will plot it too, but do you remember from standing on the graph where it is? If you input a number, you get out the positive version of that number. It doesn't just have a few dots. There's lines that connect it. We didn't really have lines out there. It's not just a few dots. There's lines that connect it. When we do the parent function, we're going to connect it with dashes. We're going to connect the parent function with dashes. Now, the family, what name? Family name? The absolute value family, yep. Parent function would be f of x. When you see the word function, you want the f of x. F of x equals absolute value of x. That's the parent function. That's what I just graphed in black. Now, the equation up here is absolute value of x plus 3. We probably even did that one yesterday. What happens if we take absolute value of x and we add 3? What happens to the graph? It moves up. So the word that we're going to use is translation or translate. Translate up. And how far does it move up? 3 units. Translate up 3 units. So I can go to my graph now and just take all of those points and move them up 3 units. Guess what point I go and I go up 3 first? Guess what point I use first? The very important vertex. Because to me, once I have that one, I can just follow that pattern where they're 1 apart. To me, that's the fastest way of graphing it. So I just took every single point and moved it up 3 and connected it.
Move it up 3. Can we get the word text down though?
Right, as long as it's, now I'm not doing the best job right now of making it accurate, but yeah, as long as it's passing through the points it should be passing through, yeah. That's why I put some dots down first, just in case like I missed. It's actually really hard to draw straight lines up here, so. I should just be using the line tool, but that takes me a lot longer, and I want to make this video shorter, so. Okay, then we're going to describe the domain and range. So again, domain is left and right. So we're looking at our graph, and there's arrows to the left and to the right. So we say all real numbers. And then the range, we think the y values, down to up. This doesn't go down, it goes up. So what's the lowest it goes to? What's that lowest number? 3. So y is greater than or equal to 3. Guess where that 3 came from? Well, it did come from the vertex, but even further back, that plus 3 is what determined the lowest point. All right, the next one, and we're doing good on time. The next one we have not done. So this next one is a horizontal. We didn't do anything moving it left to right. We only moved it up or down. We flipped it up or down. We stretched it vertically. That's all we've done so far. So this is brand new. Anytime, and this stuff is also on this page over here. I just didn't want to read all of it to you. We'll eventually get there. But anytime that we have something other than x inside of the function, so inside of the function, and this is what function family? This is absolute value. And the parent function is f of x equals absolute value of x. So when I'm talking about inside the function, for this particular one, I mean inside of the absolute value bars. That's going to put it inside of the function. All the stuff we did on that TARP was outside of the absolute value bars. So anytime we have something inside of the absolute value bars, or whatever function it is, this is going to be a horizontal. It's not going to affect the y values. It's going to affect the x values. On top of that, horizontal, everything horizontal is tricky. It doesn't make common sense. Remember when we were out there and we like had plus 3 and you all moved up 3 and it made sense? Or we had minus 2 and you all moved down 2 and it made sense, right? This is not going to make sense. So these are going to be opposite operation. Not common sense. This is opposite operation, not common sense. So when I look inside and I see this minus 5, first thing is it's horizontal because it's inside. That means I'm either moving to the left or to the right. Common sense, when I see a subtraction, would make me think that way. But it's not common sense. It's opposite of what you would think. So since it's opposite of what I'm seeing here, that -5, this transformation is going to be a translate, because we're sliding, we're translate, right 5 units. So it's just opposite of what you would think would be common sense. But once we have the transformation, it's really easy to graph.
So if
Yes.
it was x minus 6, we would have to translate left
If it was absolute value of what?
x minus 6.
Minus, like that? So
I
you
mean
do
plus, I
opposite.
mean plus.
I thought you meant plus.
Yeah.
But you were saying minus, so I just want to make sure. So that would be 6 to the left. Yeah, it goes opposite of what you think. So once you can remember, if it's on the inside, it goes opposite, you're good to go pretty much the rest of the year, because we do this the rest of the year, just different graphs. Right now we're doing absolute value. Chapter 2, we're doing quadratic. We just do this stuff the rest of the year. Okay, here is my parent function I'm putting in black, and I am dashing it because it's not the real function, it's the parent. And then I'm going to take those points, and I like to start with the vertex, and I'm going to move it 5 to the right. 1, 2, 3, 4, 5. And I'm just going to graph that same pattern. To the right. We have a new vertex. We have a very important vertex at 5, 0. 5, 0. Domain. Even though I moved it either left or right, it still goes forever to the left or right. So domain, still all real numbers. All real numbers. Range. How far down to how far up does it go? It's pointing up. How far down does it go? To 0. The 5 is the x value. The y is the 0. So we start at y is greater than or equal to 0 for our range. Just because we have like an extra couple seconds, I just want to open up our assignment and just show you like what you could do. If you didn't get that last thing because I went really fast, I can put it back up after I go over this. So you all, there is a worksheet at the very bottom of today's module, but it won't be due, like I said, till Tuesday, because we didn't go over all the transformations. We went over a lot of them, and we definitely did a lot of them on the TARP yesterday. So like number 1, 2, 3, we did all of those on the TARP. You should be able to answer 1, 2, and 3. Number 4, number 5, number 6, you should be able to do, because that we all did yesterday. This was new today, but it's not hard. You just do the opposite, and I'm pretty sure we literally just did this one. Okay? So those you should be able to do at this point. Now, can you do 10, 11, 12? Maybe. But I would say starting at 10, 11, and 12 would be the part where if you were going to do some of it before Monday, do 1 through 9. And then on Monday, we'll finish going through some of these notes so that you can finish the rest of them. They just get more complicated through there. You might be able to do 10, 11, 12 if you figured out what to do with a very important vertex. You could probably do those. But after that, we'll definitely need to go through it together. Okay?